Hi, this is Koiro with another hopefully interesting video for you. I went down to my shed fully motivated to do some fault finding on the Plus 4 that I had on my bench. But I actually got really sidetracked and the whole evening went to this sidetracking project that I hope you find interesting. To test my own Plus 4 and maybe take some chips out of this to test it, I actually have to make my own DIN plug, because I don't care much to do some just pin insert in my Plus 4, and my Plus 4 that I'm going to use for this is one that actually was fixed by Tommy at Arctic Retro. The 8501 in this was dead and it's replaced with a 6510 and an adapter board, and the kernel is updated so that the tape and everything is working, and it's somewhat retro-brighted and cleaned, but it's not recapped. And this machine has the original 4-pin plug, and even though I have an original Plus 4 power supply, they actually suffer the same problem as the Commodore 64 power supplies, with the built-in voltage regulator that leaves a much higher voltage if it's getting old and tired. And I can't find it at the moment either. It's probably stored away someplace deep down in the storage bunker or up in the attic. There are some ready-made adapters for the Plus 4 power supply. They actually have this on this webpage keylog.com that has their main business at selling keyloggers that you connect to the Ethernet. So they have some adapters here. They sell for the 128 and also for the Plus 4. And this one is a ready-made unit wrapped in plastic and ready to go. But what's the fun in ordering something ready-made that you actually can make yourself? And this is actually the same mod we did on the Plus 4, but we changed the connector. We did not make an adapter like this. And they also have adapters for C128 power adapter that you can connect to your Plus 4. There are some square DIN plugs available on eBay and others, but the 5-pin one for the C128 and Amiga is the more common one of those. And there are several variations of this plug, and Commodore even used some where the whole piece except the pins were made of plastic. So I guess 3D printing is an option. But we are going to use some thin sheet metal. This is about 0.6 mm thick and is called plastisol, as it's covered in plastic sheeting on one side and painted on the other side. We will start with this small piece, and I first cut this 12 mm square piece of wood to wrap the metal sheet around. Then the rest was using a vise, a hammer and some steel cutters to form this into something that in somewhat degree resembles the shape of the framing of the DIN connector as we see it in the picture. The result was not all bad, and with some degree of imagination we can see a slight resemblance, and it even fits into the connector. And also the polarization is taken care of with this notch on the top of this that is bent to fit into the polarization mark on the connector. So we are now one step further to jury-rig the Plus 4 power. And I actually do have a Plus 4 power supply somewhere, but I'm not able to find it right now. And I'm just going to make an easy fix for this. I have these pins. That actually is about the same kind of pins that is in these DIN sockets. Yeah, you can see it better here. They have the same length and about the same shape as these ones. But I can't reuse any of these plugs just out of the box, because this square shape, even though these are this way and these are this way of these fastenings and springs on the side, there is actually none of these round plugs that have holes fixed in a square like so. So my first thought was to just use this kind of copper and solder them together to make this a square fit like this. But as I made this one, I'm going to just make a quick adapter on this, and to make that I use 4 of these pins, and I've taken a small strip of Veroboard PCB and I've just drilled it so the 4 holes that fit this will be like so. And then I am going to solder this and solder leads onto this, and I'm going to put this one like so in here, and I'm just going to fill this with epoxy afterwards. So that will be a nice plug, but of course I do have to cover this up with some tape or something so I don't fill this plug with epoxy. So that will be the hard part. I'm just going to make a connector like so, and as we know from last time, we can check this here. This pin here will be the plus 5 volt, and this will be minus 5 volt, and this will be the AC voltage. So I'm going to solder this straight to the pins on the PCB that we have made. And the leads we are using is salvaged from an old power supply, and even though this is not the best kind of wires because they are not real copper wires but some sort of iron metallic, and we are going to use the 2 black wires for the AC line, and we are going to use the yellow for the ground wire and the red one for the plus 5 volt wire. Not the nicest one I've made, but hopefully that will hold. When I fill this with epoxy, it will actually be impossible to fix this afterwards if there are some leads that will not work. But this will be the finished plug, and as you can see it fits nice into this. And I have to cut a small hole because in this I have this keying here for not putting this the wrong way around. And as you can see from what I've made here, the topmost pins are the AC line, and that means that the keying will be on the top, so the keying will be between the black lines. So I will just take a file and cut this a bit down. And this step is extremely important. This tape is meant to avoid the epoxy from drawing into the contact that we use as a form, and we use 2 layers of tape so that it will be a bit thicker, and also so that it will be a bit more sturdy and go into the holes a bit better. So we just put some small holes and we cut with a small sharp knife around the tape, and that will make the parts go in easy, but they will also fit so that at least so little as possible of the epoxy will get into the contact. And we will also take this tape around so that the epoxy will not leak out around the keying on the plug. So now is just to fill this with epoxy. The epoxy we are using for this is just run-of-the-mill stuff, and this is bought on the Biltema store, and this is normally see-through epoxy that should be really fast drying. Any epoxy will do for this, and it's just about filling up this nice and good and get rid of most of the air. And I will leave this to dry maybe until tomorrow. It's very important that it's good and dry before we start to pull the leads and other stuff, and it also can be a hassle to get it out of the plug if there are some small piece of epoxy that sips through. And I just leave it here to dry, and I'm just using this clamp to hold it upright so it won't drop some of the epoxy over the edge. Yes, this is the day after, and we have to remove the tape to see if everything went as smooth as it should. And this tape can be a bit hard to get off because it's always mixed in with some epoxy that has strengthened the glue. And you also here have to remove this before you can remove all the tape, but as we can see, this can prove to be a bit difficult because there has leaked some glue into the crack where I had the polarization notch. We can see that more cleanly when we lift this up here. Yeah, I will just try to remove some more of the glue around here, and then I will just take this in the vise, I think, and try to break it loose, because I don't think it sits very hard. The glue is not that hardened yet, and it's also a matter of how much glue there is, and it's only a very small part where the glue has sipped in. It's only in this crack. So I will just take this now and put it in the vise and just try to wiggle it out. Sorry, but I have to do that off camera due to the placement of my vise. Yeah, and it was pretty easy to get it loose, and as you can see, this bracket down here was the only place where this actually has leaked, as I suspected. And that's because this metal here was not fully closed, but I expected this to be that the tape that you can see in here, this is the remains of the tape that we used to insulate this, that this should be so a close fit down here that it wouldn't matter. But this is the finished connector in all its glory, and now will be able to fit into a standard connector like so, and this will give good electrical contact. And I don't know if I will be able to remove this tape down here, but it's probably possible to get at least the bottom layer out. Yeah, I'm not going to run a batch and serial production of this anytime soon, that's for sure. It was not a lot of work, but it did take some time. From I started this and had the concept going with these 4 pins till I put this glue into the form last night, I think it went about 1.5 hours. So 1.5 hours each plug, that's a pretty expensive plug, but I think this will be very nice to have to debug +4 computers. Now I just will be able to put a female connector on the other end to connect this up to. And here I can use something like so that we used on the Commodore 64. This is of course not the best. I should have a female that's connected into one of those, but I don't have that. So I just might put this on a PCB strip board, like the pieces I have left of this one from last night, and I can just solder it on like so and sort out the pins. And this is very difficult to see because you can't see where the pins come through the PCB in any easy way, but this strip here will be earthed and connected together. This stripe will be connected together, this stripe will be connected together, but this strip will be broken because this side and this side is the same AC connection, but all the other strips will be connected together as they are on the PCB of the +4. So I'm just going to cut this, and I'm going to solder in the wires on top of this. This is the PCB strip board, and I just broken the connections here for the AC line voltage using a small drill bit, and I've drilled these 2 holes here to fasten a strip like this to make some fastening for the cables when they run out of the circuit. And I'm just going to solder this in, and I might also do some trickery to see that the signal voltage is okay, and that I will probably do by soldering in some LEDs that will light up when the connections and voltages is okay. We are actually going to try this out with the C64 power supply. We are just going to measure out where the voltages lay to be double sure before we do anything stupid here. Anything more stupid than doing your own connector, of course. Yes, there you have 10 volt AC. There we have 5.16. First I solder on the connector, and then I take these leads. Yeah, and then it was to solder on the leads, and I will see if I will add some LEDs to this afterwards to make some kind of hover OK check. The problem with soldering this kind of wires is that first you use your fingers to twist them, so there will be some fatty acids on the surface. The next problem is that they need more heat than the copper, and the flux need to get good soaked into this, so you have to use more solder than you normally would use, but the result is okay. They solder this to the PCB of computer power supplies after all, so it's not totally hopeless. It's just so much easier if you have 100% copper wire. Okay, so now this in theory should be a working adapter for connecting a power supply from a Commodore 64 to a Plus 4. Of course, this can be made nicer, and it can be made probably in many more good ways than I just did now, but I think this will be a nice thing to have now. And here you can see actually where the epoxy leaked. It all came through this hole here, and I should have anticipated that some could leak in here, because the paper that you use for this is not very thick on the tape. So of course it could be bent and act like this. Of course, there are numerous devices out there, among others the power saver for the Commodore 64 and other computers that will hinder the overvoltage from the old power supplies for the 8-bit Commodore computers. But I was thinking, just to make sure that you don't have any additional sources for error in your circuits while you use an adapter like this, it's okay to have some sort of test, so you can actually see that the device is delivering power as it should. So I'm just making this simple circuit to make sure that the AC voltage is AC voltage. The capacitor in series with the light emitting diode, the LED, and the resistor will see through that all the DC components will not get through. And you have to have one diode in anti-parallel with the light emitting diode, because an LED only takes 3 to 5 volt in reverse voltage, and the Commodore 64 have from 9 to over 11 volt out on the terminals. The plus 5 volt is another matter. I could have used comparators, I could have used Zener diodes and other stuff to detect that the voltage was within range, but nowadays the meters that you can connect to this is really cheap. And in my drawer I have a bunch of these cheap China 3-digit 7-segment voltmeters. These are rather small, and I was thinking that I could fit one of those on this small PCB without it taking too much space. So that's what I did for the plus 5 volt. And the kind I have is the one with 3 leads actually. So I connect together the yellow and red and have both the supply and measurement connected to the same terminal. And black goes to earth, of course. So I just made this small circuit and I soldered it onto the PCB, and it looks like this. And this is quite a versatile thing. It's a plus 4 adapter, but it also can act as a tester for C64 power supplies. And it will have a red light if there is AC voltage, and the voltmeter will tell you what voltage you get out from your C64 power supply. So that's it for this side tracking video. In the next part I will actually plug this into my plus 4 so that you can see that it's working. Thanks for watching, and hope to see you in the next one. Please hit subscribe.